Howdy, hackers, and welcome to another episode of FairLight TV. The ambition of, one of the things I read about YouTube is that you should be really consistent with your content, and be rather narrow, because then you can attract everybody who's interested in that area. And the ambition here is to have sort of the perimeter being the scene, anything related to sort of the scene, which means that anything demo related, anything sort of hacking protections on software related, and also on C64, Amiga, and PC, and whatever other machine might be of interest to sort of scene people. Having said that, one of the things that I can sort of easily provide myself would be anything that is machine code on the C64. Hacking loaders and stuff on the C64, but also sort of coding demo effects. Again, I'm not a demo coder, but I know a few of the tricks, and one of the things I can do is reverse engineer, so I can easily reassemble somebody else's code and show you how it's done. And I've done two things this time. The first one is I've done sort of a variant of the episode 65 sprite thing, which is introducing perimeters for how you can control the joystick, and there is the introduction of the concept of ghostbyte, which is also one of the things you might want to learn about. And the next one is ESCOS. 1001 crew, I think this is in 86, blew everybody's mind by showing something that was sprite all across the border, fully into the borders. Absolutely stunning and totally groundbreaking at the time. So I would show you sort of their code. I've taken their code, I reassembled their code, and I sort of polished it and did it more Bacchusified. I hope you like it the way it is, and that makes it totally portable, so you can move it around in memory, which it wasn't in the beginning. Now you can put it on basically on any location where you want to have it, and the original location is free, and it's also like 1/4 of the original size. But over to coding demos on the C64. In the previous episode, I had one segment where there was a little sprite that you can control using a joystick, and I've expanded on that. So this example is basically, it's quite similar to the previous one. It's just expanded. Let's see what we can do here. And okay, so here you see I've cleared the screen, and unlike the previous example, but you're still kind of back into basic. So I'll do hello again. So basic is running, and you see the FLT here, which is of course the sprite. The few additions here I've done is, first I've opened the border upper and lower, and then I also added this little here, the indicator that shows where that sprite is. So it's one of those routines that I've written 100 times, so eventually I wrote it down and have it as a snippet, and there is basically no way I could improve that even further. So feel free to nick that and all of that. You see on the gray where the raster interrupt is happening here, and again, depending on where I am on the screen, it could be that it takes a bit longer, but I'll show you why that happens. And the tearing effect that we discussed last time is still here, so from the tearing effect now, you could see where it's actually storing the position of the sprite. What about this black thing that is in the upper and lower? That is the ghostbyte. So when you're opening the upper and lower border, you need to set the last byte of the VIC bank, the current VIC bank, to either 0 or FF. To ensure that you don't have any like patterns, unless you want to play with it for some reason. One of the most recent FairLight release is one by Trident, where he's playing with this this ghostbyte to ensure that he gets sort of a visual effect on his scroller. So he sets sprites in the upper and lower, or in the lower border, which is a scroller, and then he's playing with the ghostbyte to make that expanded sprite scroller look like it's actually high resolution. So it looks like he has full resolution, even if it's actually expanded sprites. And what he's playing with then is the ghostbyte. So when I'm moving up and down, I'm changing the sprite color, and when I'm moving left and right, I'm changing the ghostbyte to that same value. So if you see here, I have 81, and now we have which means that it's 81. That is the value that is in the ghostbyte as well. Now you have 7F being in the ghostbyte, so it's quite clearly totally black. Save 1 pixel row. It's just to introduce the concept of ghostbyte. Visually, it looks like crap, of course, that you're playing with it, such as this. So it's only to introduce the actual concept of ghostbytes. And what wasn't implemented last time was also that now it can actually move beyond FF, and it's doing that consistently. So I'm actually adding that extra bit of DO10 if it passes that. So if it's FF in the X register, then it now turns to like hex 100. So by setting it to 0 and then setting that high bit in DO10. The routine still only like prints the last byte, but you can see here that I've actually set it properly, so you can go back and forth between the last two, the first 256 or hex 100. Sorry if I'm not consistent with using decimal and hexadecimal. That might be an issue. I should try to be really clear on that. But I also implemented sort of a stop. So if I go right, I'm stopping at address 58, and that is sort of the first address where the sprite is totally hidden by the side border. If I just go 1 pixel, it's very difficult to go just 1 pixel here. But if I go 1 pixel, you can see that it's now in the border there. So you can actually see the sprite here, but now it's fully hidden. But if I could do 57, yes, I could do 57. And now you see there is actually 1 pixel here. And then I let it run to the other side, and I am stopping at 0. Yes, actually 0 is where it's totally hidden. And if I manage to get like 1, that's difficult, because there should be 1 pixel somewhere there. I don't have that many pixels on the very right. It's just like the top edge of the T here. That should be now kind of sticking in two pixels there. You can see under the cursor, like 3 cursors down, there is this little cyan dot. Okay, let's have a look at the code for this. Setting up the raster interrupt, that was explained well last time, so I'm not going to explain that again. And again, copying the sprite to the tape buffer, the very handy non-used area, which isn't colliding with basic, but still not messing with the VIC bank. So this is the first VIC bank, the one from 0 up until 3 FFF. And then setting the pointer to that sprite, enable that single sprite, and then setting it to this sort of pseudo-random place in the middle of the screen, clearing the screen using the kernel character out. And then this is the raster interrupt. the first thing is doing is setting it to 24 rows and then to open the border. And I guess I was a bit lucky that it's not flickering. It's I haven't seen any flickering when I'm using this, so I guess this works fine. Setting the color based on where you are on the X direction. And then my my little routine here is checking if I'm doing joystick up. If it's not up, then it passes to this. I used exclamation marks because I inserted more code here. I really needed like real labels. Down, it's very much the same. There is no real change. Whereas left and right is where you have changes. So if I'm doing left, I need to check if that high bit is set, and if so, I need to compare with. And now it compares with 0, which means that, and you don't need to do compare with 0 because when you do an LDA, and if it is 0, the Z flag is set in the status register, so you can do the branch without doing a compare. So you look really stupid if you do a compare with 0. It's rarely needed. Okay, and then if you should decrease D1000, so the X register here, you do that. And then if the X register here is wrapping to FF, that means that you should clear the DO10, so the high bit here. And then you're doing the same, but moving right instead. So if the joystick isn't indicating that you should do right, then skip all of this. But and then you should handle it differently depending on if this high bit is set in DO10, exactly like left, but only sort of the inverse. And here you see the 58, which is the comparison value of the outmost position that I'm allowing on the X dimension here. Yeah, that was that. And the toggling of expanded, we didn't see that. And I guess it doesn't really matter. So, and here I print the $sign to ensure that you know that the address is given, the current position is given in hex. I'm reading the value from these D1000 and I'm setting Y to 1. I'll show you why I'm doing that. And then I'm calling this print routine. And then I'm doing reading D1001 and then setting Y to 5. Well, I can already tell you, this is sort of the offset. So I have defined sort of the starting point. And then when the routine is called, I use Y as an offset marker to where the characters are supposed to be printed. And then I'm resetting DO11, and there needs to be sort of, here I had a delay routine before to ensure that setting it to 24, and then I needed to wait before I could reset it to 25. But since I'm doing the print here, that's consuming that sufficient number of cycles, so I can reset it without having any delay or anything else here. And then taking the X register here and storing in 3FFF. That is the ghostbyte effect you saw on the upper and lower border. Decrementing DO20, so turning the blue. Well, the increment turned it to gray and then turning it back to blue here. And then DO19 jumping to EA31, so the interrupt service routine, including handling of the keyboard. And then the definition of the sprite. Okay, so what I have here is the print routine. So I should print a hex value. And the hex value is derived from the lower 4 bits and the higher 4 bits. The lower 4 bits is one character, the highest 4 bits is another character. So I'm pushing the accumulator, which means I'm pushing the value I'm going to print because I'm now going to extract one portion of it. and I'm increasing y, so it was 1 when I called it the first time, so now it will be 2. And then I'm masking out the lower 4 bits. I only want sort of the lower one, so I'm printing the rightmost character first. And then think of this as the print. And then I'm pulling the value I was storing on the stack, and I'm decreasing y. So it was 1 when I started. I printed on 2, but I'm now back on 1. And then that value, I'm shifting that to the right 4 times. So the 4 times LSR here means that the 4 top bits are moved down to be the lowest 4 bits. And I'm shifting in a 0, so there's no risk I would have something that is, I would have a crappy value. I don't need to do an AND to ensure that I get rid of the top bits, because the LSR ensures that zeros are shifted in. And then I'm doing the actual printing here. So I'm transferring A to X. So what was in the accumulator is going to be an index to the table where I read the corresponding value. And then I'm storing that to wherever I want to print it, comma y, and comma y was the offset of my sort of print area. And then I'm returning. So you see the clever part here. The lowest part is used here. And then I'm doing additional things, and then I'm doing that again. And since I'm going to use screen code upper, this is a table of hexadecimal values, so 0 to F. Yeah, that was it. Let's try to run that again. And that was it. And shifting to, and you can see here the values printed as I described previously, and the sprite doing what it should, and you see the ghostbyte changing, and yeah, works fine. It does what I intended it to do. It might not be graphically stunning, but the intention was to do sort of a technical demo showing the technical features rather than showing something that is also visually stunning. Speaking of ghostbyte, I of course need to show you this. And here we can turn, load FLT, 8. Yeah. My cursors aren't working because I have the joystick enabled, so it has to be like this. So I've basically only done one real demo part. It was in, is it 88, 89, something like that. Digesta, I should be able to, I have it on the screen. So it was released on the 25th of March, 1989. That will be in Icaris Argon party in Slagelse in 89. So I will bore you now with my demo part. And the reason for doing that is that, and I will, even if I love the music, I will turn it down. Okay, so this is my demo part here, and what you see here on the top is that's a scroller which I could control using using the joystick here, and then I do FLD, and so the lines you see floating across the screen, they are normal character lines where I apply FLD to show them in different parts of the screen. But what you see in the background is this magical the ghostbyte. So that one is so I basically on every raster line I guess I take the value from DO12, so the raster pointer, and then I'm picking the value from a table, and then I'm storing that to the ghostbyte. which means that for every new raster line, I get something that I can poke into the ghostbyte. So the ghostbyte is the same for all the 40 characters, and then I just updated it per raster line. And when I hit something which is showing the a character line, of course, I'm not fetching any ghostbyte. Or if I do that, it's still hidden by the character, so it doesn't really matter if I poke it or not. But that is, so just showing you that ghostbytes are not only available in the upper and lower border, they could be, they are also what you see in the background if you do FLD. There are a number of times when watching demos on the C64 that I have been totally blown away from stuff I absolutely wasn't believing would be possible on the platform whatsoever. And one of those would be ESCOS. It's filling the entire screen with sprites. So you have like a mat of 8 sprites times 7, so you have a mat covering the entire screen, upper and lower, and also out in the outside borders, the side borders. 1001 Crew did this, and it was, for me, it was totally mind-boggling that that would even be possible. And I've reassembled their routine, and then I sort of refined it, because there are a number of aspects that could be shortened and could be written in a way which I find more. Yeah, first of all, it's a lot more compact than their original routine, but I would like to also kind of stress that this is sort of the original code. I just refined it into something else. I didn't invent anything here, and I didn't do any new timings or whatever. And so everything I wrote here is sort of replacing parts of their code, so it would be smaller and more efficient. Yeah, so one of the kind of first things one needs to understand is that in order to do ESCOS, you need to have supercritical timing, because opening the side border requires supercritical timer on the cycle. You cannot be one cycle off, then the effect wouldn't happen. So you need to have a stable raster interrupt, and you need to open the border precisely where it should be opened. And here, one of the things that is sort of an issue here is if you have a branch inside your routine, if the branch isn't taken, it's 2 cycle. And if the branch is taken, it's a 3 cycle. But if you pass a page boundary, it's 4 cycles. So for that particular reason, you cannot have a branch that takes kind of the border, the page border jump, because that would be different, and it's very hard to make that predictable in your code. So there are a number of times where there are delay loops, and they had them as an X and then decreasing that, and they had like routines set on pages, and I removed all of that to make that into a call to a delay loop rather than having the delay between every section. I'll show you this. It might sound very confusing when I explain it, but that means that I could compact everything. I just need to set the start address, and there are no like even page boundary routines here. Everything is compacted into one set of code. So the first thing here is, what are we going to try, or what are we trying to achieve here? So first of all, on the very, very top, you have a raster interrupt at the beginning of every frame, so every screen drawn, so to speak. That needs to be stable. And the way to do that is that you set one, or there are multiple ways, but the way they have done it here, and which is probably also the way I would do it, because it's sort of the easiest way, you set the raster interrupt on one line, and then that raster interrupt is only doing basically one thing. It's setting up a second interrupt, and then it's going into a long set of knobs. And why is it doing that? Because a raster interrupt is, or any interrupt, is asking the CPU to pause what it's doing and then moving into servicing the interrupt. So the CPU would service the interrupt rather than doing what it's like the standard routine it's doing. But it needs to conclude the instruction it's on. So if it's on an LDA whatever address, X, that could be a 5-cycle instruction. And that means that if your interrupt is triggered on the kind of the first the instruction, or the first cycle of the 5, you would have the interrupt service routine could flicker a number of cycles back and forth, and you couldn't have that. So there needs to be a mechanism to ensure that you have something that is absolutely cycle perfect. And what you do is you set up a first raster interrupt which is basically doing a lot of NOPs, but the NOPs, they are 2 cycles. So the subsequent interrupt would be sort of wiggling between 1 and 2 cycles. So if you have the second interrupt triggering on the NOP's first instruction or first cycle or the second cycle, that's the only case you need to handle in order to have that. And the way it's done here, I'll show you I can show you directly. So first line raster interrupt here, and then it's on sort of the second one here. It reads DO12 at the very end of the screen. So if you are on the first cycle, you would still be on the expected line. And if it's on the second cycle of the NOP, the DO12 would be sort of one line further down. But then you need to read it specifically. You need to read DO12 specifically where that effect sort of happens. So you read it at the very end of the line, and then you do a compare for DO12. And if you do a compare, you can do a branch to the next instruction, and that would be 2 cycles if you are not taking the branch, and 3 cycles if you are taking the branch. I hope that was understandable. It's a bit complex, but think of it. Think of the first interrupt as ensuring that you can only wiggle between like 2 cycles, whereas normally you could have a much bigger wiggle. And then that routine also is just filled with NOPs. And you break that using a second interrupt, which needs to handle this little case of just wiggling between 1 cycle. Okay, so that is ensuring that you have a stable raster interrupt, or you know exactly where you are, which cycle you're on. The second thing you need to do is ensuring that you open the lower and upper border, and that's the orange thing here. When you are on that very last row of the screen, you are setting the screen to 25 lines, and then when the raster is drawing that last, like the 25th raster character row, you are decreasing it to 24, and then the raster will never see that it has reached the end of the visible screen. And when you then also expand back to 25, after the raster has passed that like 25th row, then you would have the border open and closed, and you are prepared for the next lap. So that's the orange thing here. And then you have the red. On every raster line, you need to move between 40 columns to 38. And when that happens, you open the border on the side, and then you need to set it back to 40 immediately afterwards. So you are sort of ready for the next screen line. And then you also need to do a sprite multiplexer. So first of all, you set the sprites to somewhere up here, and then sometimes during painting that sprite, you can set set the registers to like a new position, and then the sprite would appear there, because after it's done drawing the first set, it will start from what it has in its current register, and that is sort of the updated one. And here, so one of those purple lines would set the, or that's showing the block of sprites that is sort of in there. And sometimes between two purple lines, you need to move them to like a lower position at the start of basically the adjacent purple line. Yeah, not very easy to explain in a coherent manner, but yeah, but that is sort of where it is. Okay, yeah, why don't we do like this? And I will run. Oh, that's ugly. Can we make it like more square? That'd be sort of square. No, it's not even square. What is this? I think I might have extended. Do we have normal borders? There should be normal borders. That's weird. Okay, let's do it like that. I have, when I assemble now, I inject directly to the memory, but since I have the cartridge starting, I need to have, I need to call the routine directly. So this is what ESCOS looks like. Here you see something covering the entire screen, stretching all the way out in the borders. It's quite massive, isn't it? I mean, yeah, you're showing a picture because, and if you're running this on a PC, it's easy to show something as that. But this is running the emulated machine, which means that it actually happens like on a C64. And when I saw this the first time, I was, that's not possible. How are they doing that? And it's quite complex, as you saw on sort of the theoretical description on how to do it. Let's do it like this. Okay. It will be difficult to see this possibly if you're using a mobile to watch it, but yeah. If it's too difficult to read, then please watch it on a big computer so you can zoom in and see it in full resolution. Yes. So what I'm doing first, there are a number of things I'm doing, or which 1001 crew is doing, which is here in my code. I'm not saying I'm doing this. First of all, you need to kind of set up, and if you want to on every one of those purple lines, you need to move the sprites, the Y pointer of the sprites, down to kind of the next segment, but you also need to change the sprite pointer so that they are pointing to the relevant content, where the actual kind of sprite data is. And there are basically two ways to do this. You could populate the last 8 bytes of the current screen memory, or you can pre-populate 7 screens here, and then you just change the screen pointer to point to the current screen memory that has the pointers that you would like to use. And the latter option is used here, because then you only need to change DO18. So you just need to change the address where the screen memory is at. Okay, so this is a very silly loop. So I'm using the second Big Bang from 4000 to 7 FFF. And the screens are from 4000 to up, yeah, wherever they need to go. And then the sprite memory is at 6000. So, and that means that the first sprite is on sprite slot 80. So the first 8 sprites are 80, 81, 82, 83, 84, 85, 86, 87. So these are the ones. So I'm just having something that takes count, and that is sort of, because I'm moving 8 sprites, or I'm populating data for 8 sprites. adding that to 80, and then store it at the sprite pointer for the first screen, and then taking the counter, adding 88 and storing it to the second screen, the third screen, and so on until the last screen here. So you have 1, 2, 3, 4, 5, 6, 7 blocks of sprites. And then I just increment, and then I call that again to have like a loop that copies 8 values. So pre-populating 7 screens with relevant values. This is, if you've seen the last few episodes, you know how to set up a raster interrupt. So this is turning the timers off, setting IRQ pointers to the IRQ vector. It has a block of data that it copies to VIC. So all the standard values are there, including DO1A. So the raster interrupt is triggered using this as well, or set up to have the raster interrupt. And then it's setting VIC bank to the one starting at 4000, ASL 19 to clear any previous interrupt, and then CLI for setting the or clearing the interrupt restriction flag, and then storing 1B to the count. That is sort of the most tricky one. The count is then used to store into DO11, but for reasons which are quite difficult to explain, you cannot just do LDA 1B here and then store to DO11, because then you get a glitch. So you need to have it with something that is FF. It's sort of a ghostbyte thing. And then it's star -3 means that it's just looping. It's calling itself indefinitely, so it's doing that. So DO18, that is the value that the program is going to copy into DO18, and it's pointing at the screens which I now prepared with the respective screen pointers or sprite pointers. So screen 0, the one on 4000, and the one on 44, the one on 48, and so on. So these are the values for that, and 7 is just pointing at the font, and that's not going to be visible. So the lower nibble could be anything, it doesn't matter. And then VIC defaults. Here you have the X and Y for the sprites, and then you have the high bit and DO11, DO12, whatever. So here you see triggering DO1A, so setting the raster interrupt but disabling all the other VIC sources. And these are sprite colors, so color 9, color 7, and then 8 times color 8. Okay, a lot of what the program would eventually be doing is that it would delay. So it's done its DO16, and then it could wait until it could do the DO16 again. So there is like a block that has an RTS here. So if you do a JSR delay 12 directly to the RTS, that would mean that the JSR takes 6 cycles, the RTS is taking 6 cycles. So that call to a dummy subroutine will take 12 cycles. And then I'm just adding knobs, so you can get basically any number of cycles here, any even number of cycles consumed here, but just waiting. And so that's one way of doing it. This is what I've done. I've implemented this rather than having little dummy loops that could risk kind of jumping across a page border. Okay, and then the first interrupt. So it's triggering on line 0. And then it's setting up a new raster interrupt to be triggering on row 2, clearing the interrupt flag, and then setting the new address for the secondary interrupt, allowing interrupts to happen. I don't think this is actually needed because I don't think it's set at any point. So that could probably be removed, but you don't save any byte. And then you see a long list of knobs here. And the only reason is for the reason I discussed before. you would have the CPU doing a NOP instruction when the next interrupt happens. And yeah, so I am actually scrolling here, and then it has a jump FCE2, that is jump to the reset. So the only time this could ever happen is that the CPU never kind of the second interrupt wouldn't be triggered, and then something is wrong, and then the program just resets. Yeah, there are possibly other ways to do it, but that's the way its program is doing it. It's getting annoyed that it doesn't get that second interrupt, and then just resets. And the second interrupt is doing this. It's delaying. Bit EA is just a delay. If you want to do a delay of like an odd number of cycles, bit EA is one way you can do it, because that takes 3 cycles. It's not going to do anything for you. It's just a delay of 3 cycles. And then it reads DO12, compare if it is on line 2. If so, then jump. Otherwise, you're fine. So I guess you should be bordering between line 2 and line 3 here. So if you are still on line 2, you should have that extra cycle use. So when the branch is taken, it takes 3 cycles, but if it's not taken, it's only 2 cycles. So that is what it's doing here. It's branching to the next instruction, and you are reaching the next instruction. So programmatically, there is no point. The absolutely only point is ensuring that you pad like 1 cycle of your code to ensure that you remove that 1 cycle jitter. And then delay, yeah, I mean, the details here are kind of shown in my previous, on the slide I showed you, and that is everything it wants to do is ensuring that the increase and decrease of DO16, which is what it's doing to open the border, happen in the right place, that the sprites are moved when it's time to move them, setting them to a new direction, to a new location, and also change the screen pointer so that the actual content of those sprites are what you want them to be. And then also opening the upper and lower border, because if you don't do that, then the side border openings won't happen here either, I think. So yeah, well, and some happens in the main loop and some happens in subroutines. It might be difficult to read. This will be on GitHub or GitLab, so you will be able to fiddle with this yourself and see if you can play with it and see what happens. But I'm just scrolling here. Yeah, so most happens in subroutines. The set sprite Y is also set. It's setting the sprite Y, and it's also setting the DO18 to the proper one. And X holds which sort of sprite bank we're at. Here there was seemingly not cycles enough to make this into a subroutine, so it's here in the sort of main part. And you also see it's squeezed in DO16, deck DO16 and ink DO16, so that is the border opening. In the middle of populating the sprite pointer, it's doing that. Yeah, it could do it there. That's absolutely fine. And then it's updating the DO18 table, so pointing to the next set of sprite data. Yeah, so you could, if we go back again here, so it's the first set of sprites is on row sprite or on line number 4, and then you have the next. Oh yeah, so the next is on 2E, 58, 82, AC, D6. And here it's row 0. And to be honest, I'm not really sure, but so when it's doing LDA 10 and storing to DO11, I think that's when it's opening the upper and lower border. Yeah, you can play with that as well if you want to, but and it's doing this silly thing DO11, Y That's really strange. Y is 0, and the only reason they are doing this is that they need to pad 1 cycle, and there is no like NOP 1 cycle NOP. There is only a 2 cycle NOP, so you need some other mechanism to pad 1 cycle, and this is so the comma Y. The only reason they are doing that is to pad 1 cycle. Yes. Okay, and then here everything is done. So paint 40 lines is the last thing, and all the sprites are done, and now you're at the very, very last part of the screen. And then it sets up the sprite pointers to be on row 4, which is again the top where it's supposed to be when you latch IRQ2. It sets the original DO18 to 07, and of course resetting the DO11, so the 24 versus 25 line, so that you open the upper and lower border. That is also prepared. Setting the raster interrupt to line 0, and the new IRQ pointers to the first interrupt, the one that is only used for stabilizing the raster. Setting the or clearing the raster here, so that everything is prepared for receiving another interrupt. And what it's also doing here, it's pulling the previous interrupt. So you had an interrupt happening, and then you had another interrupt happening, and whenever an interrupt is triggered, the accumulator X, Y, and processor status, they are stuffed to the stack. So this is pulling it back from the stack because it's dummy values. We don't need that. So we can allow that. We pull the status from kind of the current interrupt. So when you eventually then finishes an interrupt, you're actually finishing IRQ1 because this is removing all the traces of IRQ2. That's also one of the things you need to learn if you want to do a stable raster. You need to clear the raster, the interrupt, so it's servicing. When you're calling the EA81, you're servicing the first interrupt and removing all traces of the second one. Okay, this is a service routine. It's calling repeatedly, where it's setting the sprite values to something which is in the accumulator when this routine is called, and then you have DO16, so the border opening, and then setting DO18. So again, the next screen is used, and then increases so that everything is prepared for the next time you read DO18 table. A little more delay, and then opening the border again. Handle a line is a messy one, because this is where it's fiddling to ensure that the sprite point or the character point doesn't happen. So it's fiddling, basically tricking away so that there are no bad lines. So handling to ensure that you don't get any bad line. This is what that is doing. And it's also, of course, whenever needed, opening the border as it should. And then a massive section here, which is handle a line. So it's basically calling this. And here I also include the picture. So I saved from Tutankhamon 2 by 1001 Crew. I think that was it. So let's run this again, so you see the end result of this. ESCOS, the super invention by the 1001 Crew. Humble credits to the guys from 1001 Crew. This is amazing. So just adding one little segment here, and that will be my reassembly of the original ESCOS routine. I'm just showing you a few of the things that I changed, and well, you can compare this with my end result if you want to. They are quite different, but I haven't changed that much. Well, if you look at them, they might look very, very different, but I've just taken their original core and altered a few of the things that I wanted to change. First of all, like make it more compact, ensuring it was portable, so you can have it like any place in the memory, removing loops that can cause this branching over page boundaries, which makes all the timing go haywire. Okay, so I'm using 6502 bench, which is sort of my go-to place now for reassembly for the 6502. The only sort of weak spot it has, it's not handling KickAssembler, so the source I'm doing with it is sort of a pseudo source, or I make turbo assembler and then I need to change turbo assembler to something else. So I should just show you what I'm doing here. So what you can do is it like this? Oh yeah. So that was I just copied everything from the 6502 bench, and then I pasted into this turbo assembler to KickAssembler converter. It's done by Swoffa, so Simon Oskarsson, the same guy that has done the glue between Sublime and KickAssembler. So, and this is by far not 100%, but it saves you so much like fiddling work. So it's doing changing all the comments and handling all the colons after the labels and all of that crap. You need to change a number of things to ensure that it actually works, but if you do this and then assemble it, and then you just fix the little few things that it doesn't handle, and then you're good. It saves you hours of work, so I could strongly recommend that. Okay, well, showing you the disassembly here. First of all, it's doing a. I'm kind of keen to always try to optimize stuff, and storing 0 to D01A. It's already done in the VIC default, so that one is gone. Also storing to DO20. Why is doing that? Just store the correct value here, and I'm not sure what this bitting of DO21. I think it's mainly done for like debugging purposes, so you would see where sort of it's handing back stuff to outside of the interrupt. So a lot of that is removed. There is a string that says copyright 1001. Sorry, I've removed that. I have that in my assembler header. I hope that's good enough. And then it's a padding. I just removed that. The DO18 table, that's a bit weird because, I mean, it has so many values here, but only the first 7 are actually used. So I've cut that down to just covering the ones that are actually used. Then you have the VIC defaults. That one is actually extending a bit too far because, I mean, DO2F is not applicable. It's a register that works for the 128, but it's not used on the 64. So I'm cutting that out as well. Here the IRQ is only setting the low byte. So what you see here is that the IRQ here is on C100. And then it only needs to set the low byte because the IRQ2 is on C200. So I'm setting both the low byte and high byte. And then, yeah, the DO19, I'm doing that a bit more efficiently by just doing the ASL thing. Removing the setting of colors because again that shouldn't even be visible, so removing that, and then the knobs are all there. And then it's this is sort of also a debugging thing. It's loading DO12, storing it on the very last address here of this little block on the C block. And I guess that's for debugging purposes as well. I see no other reason. So if read DO12 before it's doing the reset and see what that was. So yeah, there is no point for the actual program to run. It's just for somebody who wants to kind of fix their code. IRQ2, you see here it's on C200 and a lot of that. And then you see all of those. Here you see a routine that's looping, and no, it's actually, this is the loop. So I removed all of those, because if those go over a page boundary, then things are going south. So you don't want that. Also, this store in 0500, there is no real point in that. It's not doing anything. It's basically doing stuff that's just delaying. Storing stuff in 0500, it's not used for anything here. So also gone. Yeah, another loop. So all those loops are replaced by a call to this my list of knobs and an RTS. Yeah, most of this would be then the same, and then stuff like that. I could move that also, replacing that with a call to this my loop, my general delay which has a lot of knobs, so I could just pick the correct number of delay knobs that was needed for this particular case, and then use that. So setting sprites, I guess that's the same. I guess this is the same. It's using EA7E. I'm using EA81. The only difference is that it's sort of clearing a timer interrupt, which isn't called in the first place. So I could easily do that. That's this routine, storing stuff in 0500. Not really used for anything. I just replaced that with a delay, and that works fine. So yeah, there is an RTS here in the middle of that. That's also not used for anything. So all of that is also removed. Handle line, that one should be the same. There is one little thing here. Yeah. So here it's doing a branch to C678. So this nop, deck DO16, ink DO16, and RTS. That's actually the same as you have here. So I changed that branch up to here, and then I could remove this entire section. It's not saving that many bytes, but I hate wasting bytes. I hate duplicating code that could be reused. This is the same, and then yeah, in the very end there is this little thing. It takes if you call C800 in the original, it's printing made with ESCOS by 1001, and then you press a key and then it actually starts. It's not used here, and yeah, again, I have 1001 crew credited in the heading of my version of the source, so I didn't need to have that, I felt. So yeah, so this is sort of the original. The core part is still the same in my version. I just made it more portable and more compact and removed anything I could remove. So that's what I did. Oh yeah, there was this little thing that I wanted to show you as well. So let's see if we have that here. Hey. Okay, so this is the original TUT2. Let me just add a little bit here. Display VIC2, and then you can set border mode here. So if I set full, you see a bigger share of the screen. I might even do debug here, because that's showing even more. So what you see down here is that there is sprites down here, and yeah, in the original there is this fiddling with setting the colors to 6 and 7, so yellow and blue here. But you can actually see here that yellow is painting through here, and then it gets blue. So there is actually one raster line where they forget to open the border. So there is like sprite content that isn't shown, even if you try to sneak look at it. Whereas, so again, this is the original. I don't have any of that, so let's do the same here with mine. Display VIC20 debug. Here you see the full picture is shown. So I've just added 2 extra lines, I think it is, of border opening here in the beginning or in the end. So that means that the full picture is shown here rather than everything except the last line or 2. Yeah, and also, I mean, if you compare them, I've also moved it, I think it's like 8 bits to the left, because that is more centered on the standard settings. So if I do settings and let's do full, you can see that there is a quite big chunk of black here. Whereas if I do that on mine, full, yeah, you see that chunk is less, and I have a bit of chunk here on the right instead. So more centered. Possibly you can even move it further left if you want it like that. But it still looks good in normal settings. So it's not that we do have an issue, but I thought that was to prefer over the actual original. So yes, I fixed bugs in the original ESCOS routine as well. That was everything for today. I hope you enjoy coding demos on the C64, and if you don't, then you might still be interested in hearing how the tricks are done. So we've opened up 2 additional tricks. First of all, the one on ghostbytes. I'm not really sure that was sort of opening. It's just explaining what it is. But ESCOS was probably something you didn't know how to do. If you know, then happy for you. And the rest of you now would know how to do it, even if doing it is quite tricky. And you also have seen the examples of stable raster interrupts, how that could be done. Just if you need to do that yourself, then just borrow the code from the GitLab repository. Just download it and copy away that snippet and use it for your own good. I'm looking forward to see your results. See you next week. Bye bye.